Fine. So I gave you two circles, and you could find, in fact, two different homotheties sending one into the other. I said generically. So there are some exceptional situations. What are they? Well, you will not have great difficulty in discerning these exceptions if we go a little bit more carefully through this proof. Remember, how did we construct these homotheties? Well, by simply noticing that the ratio of similitude can take two values, possibly. And then, having found this for each ratio of similitude, we have placed the center of similitude, center of homothety. Well, there are only two possible places. While doing that, what we did was to construct the centers as points dividing the line segment O prime in this or that ratio. Now, in order for you to be able to do this, there must be a line segment O prime, and that's not the case if O and O prime coincide. So, exceptional situation. So let me write it here. So, exceptional cases, exceptions. Well, the first one is when the two circles are concentric, O and O prime. Well, so in that case, there isn't really much to do. In which case, actually, in this case, still we can insist that it happens. Yet we must take px and pint, and we must make them coincide in the point A. Well, actually both homotheties work, but the central homothety must be at A. The other, okay, so that's one thing. So let's assume that O and O prime are distinct points. So there is a line segment with which we are supposed to be divided by this or that property. I want you to remember, actually I talked about this, and at that time, I don't know whether it struck you as significant or not. I tried to make it as significant as possible. I give you a number lambda. Can you always divide a line segment in the ratio lambda? Can it be done for any lambda? Well, it can be done for almost every lambda except one. It is not possible. Okay, so well, let me use this part of the blackboard. Okay, here is the line segment O prime. If you want to divide this line segment in the ratio +1, observe, not -1. -1 would be the exact midpoint. Okay, so that's, if you take this point, it would divide the line segment O prime in the ratio, so this would be P. PO prime, it would be -1. -1 is okay. Try to leave +1. Well, +1, if you want to divide in the ratio, PO and PO prime must look in the same direction. So P must be somewhere here. But look here. The ratio of PO to PO prime to be exactly 1, it means that the vectors PO and PO prime must be the same. Is it possible? It's of course impossible. It's impossible. So this is the second exception. The second exception occurs when R prime over R is equal to 1. Or let's say R is equal to R prime. Well, in this case, you see what happens is that your circles are equal in size. So it means that if you do this construction, this x prime is parallel to the line joining the centers. So in fact, in this case, you must px has in fact gone to infinity. Or let's say there is just no px. There is, you can't construct the external central homotopy. But internal one, yes, it is there. It's the exact point. That's because it's the internal homotopy center is constructed with -1. Right. Okay, so I want to conclude this thing by giving you some examples of the. Actually, I will give just one example, which is, in my opinion, well, almost the climax of everything that I have done. I would like to revisit the 9 points. Remember the 9 points? So, this is actually the next problem sheet. But I personally would like to revisit the ground rule theorem 9-point circle. 9-point circle. Let me very briefly recapitulate. It was the following. In a triangle, remember, the midpoints of the 3 sides, the feet of the 3 altitudes, and the midpoints of the line segments joining the orthocenter to the respective vertices, these 9 points lie on a circle. Okay? So we have proven this. I gave you a fairly sort of sophisticated elementary argument. And I'm sure that it was an elegant argument. It's a beautiful thing. It's the most beautiful thing. Yet, this is one of those moments in mathematics when you say to yourself, now 9 points lying on a circle. Now, this can't be a coincidence. There must be something, some kind of hidden structure behind it. And that's exactly true. Okay, so revisiting. And that hidden structure we can see now by looking at the triangle and its circumcircle from the point of view of homotopes. Revisiting the 9-point circle, the Euler circle or the Feuerbach circle, 9-point circle. Okay. Here's the deal. Now let me first draw the triangle with its circumcircle. I will give you a fairly large picture. So that's A. Okay. I take the altitude first. Okay, so yeah. Let's see through the fairly good picture. Okay, where it is? B, C, okay, here's the triangle. Okay, so the feet of the altitudes, the one opposite A is A tilde, okay? And let's call this point HA. And I know that the reflection of HA in BC is the orthocenter, in which the 3 altitudes intersect. So this is my B tilde, this is my HP, and this is my 3rd altitude, which intersects the circumcircle in HC. Okay, so let me use a little color to make the thing a little bit like, okay, and of course this is the fruit of the altitude, which are called C tilde. Good. Okay. And what else? Right. Okay. So let me indicate these 3 points in red. Good. Okay. And yeah. And okay. So next comes the 3 midpoints of the line, the sides. So this is A prime. This is okay. So where's the okay? Stop here. This is B prime, and this is C prime, if you wish. Okay. So this is okay. So the center of the circumcircle is A, of course. Okay, right? Yeah, that. Okay, so what else? Well, I shall also, okay, so let me indicate them also in red. Good. Okay, and finally, of course, the, yeah. Okay, finally, of course, the, or let me do it in blue. Okay, so, and finally, the midpoints of the line segments, the 3 line segments that join the orthocenter to the vertices. Okay, so for instance, this, and this, and this. I think we called them K, L, M. Right, so let me again use red to indicate. So these red points, the 9 points, they are all on a circle, and we are trying, they are mystified. I mean, how come? How come? And here is the explanation. Here's, I think, what I consider to be the best explanation. Now, of course, you know that if I join O and H, and if I join A and A prime, these intersect in the centroid G. So let's remember this. I think I have not made a very good drawing, because the centroid should divide OH in the ratio -1 to 2. Okay, so this is beta, I presume. Okay, so there we are. That is G. Okay, the centroid. Okay, Schumacher. I know that GO to GH is -1 to 2. Good. So if I take the homothetic with homothetic center G and ratio of similitude -1/2. I want you to observe what happens. The point A. Okay, so let me indicate those points in green. So A is mapped into A prime under this homothetic. The homothetic has center G and ratio of similitude -1/2. So GA is twice GA prime, but in opposite direction. So A is mapped into A prime. B is mapped into B prime, the same thing, because the, and finally, so in fact I shall get rid of this completely, because we don't need that. And finally, of course, C is mapped into C prime under this homothetic. So this, in fact, sends A into A prime, B into B prime, C into C prime. Good. That's excellent. So that means of course the circumcircle is sent into the circle that goes through A prime, B prime, C prime, but that's not the whole story. That's not the whole story. And now if I use H now as center of homotheity, and if I take the ratio of similitude a half, not minus a half, but plus a half, let us see what happens. Şimdi çocuklar, remember, the reflection of H in BC is HA and it's on the circumcircle. The reflection of H in CA is on the circumcircle. The reflection of H in CA is in BA is on the circumcircle. So it means that if you take H as your homothetic center, then the points HA, HB, HC are turned into A tilde, the feet of the perpendiculars, B tilde, and C tilde. Is this all? No, that's not all. That's not all. You see, the points A, B, and C, A, B, and C are respectively turned into K, L, M. And okay, so that's rather interesting. You see, that's rather interesting. We shall ask ourselves also, what happens to the circumcircle? The circumcircle. Şimdi look at it like this. This is G. This is O. And the ratios, and here we have that H. And you are working with the ratio of similitude minus a half. So the point O is mapped into a point O prime. Okay? So that GO prime to GO is minus a half. But you see, this is the exact point of H. Okay, the circumcircle turns into the circle gamma. Okay, let me call that point E. E. But this is the unique. Okay, so this is E is in fact the image of the homothetic with center G and ratio of similitude a half of the point O. Okay, so what happens? What happens to the radius? The radius of the circumcircle is big R, and it is reduced to a half. So there it is. Okay, so what happens to the, okay, so that's what happens to the circumcircle under this homothetic. What about this homothetic? Well, under this homothetic, the circumcircle, by the way, the circumcircle is in fact the circle with center O and radius R. Okay, so what happens to the circumcircle under the second homothetic? Well, under the second homothetic, the center of homothetic is H, and O is sent into, okay, so this thing is sent into the circle gamma. Well, the radius will be a half. And what is this point, E? Well, this point E, the midpoint, the exact midpoint of AH is also the image of the point O under the homothetic with center H and ratio similitude a half. So it means this is again the thing. So it's done. It's done. We have found that this homothetic and this homothetic, they both send the circumcircle into the the same circle. The circle with center E, which is the exact midpoint of the line segment OH, and radius R/2. How many points on it are there? The images of ABC, A prime, B prime, C prime, the images of HA, HB, HC, A, B, C, which are the points A tilde, B tilde, C tilde, K, L, M, 9 points. Okay, the very same. So that is why this strange small circle has this 9 significant points lying on it. It's just because of the fact that the 9-point circle is in fact the homothetic image of the circumcircle under 2 different homotheties. One with center G and the other is with center H. With center G, the ratio of similitude is -1/2, so it goes backwards. Okay, so A is mapping to this. So the images are on different sides of G. But with H, it is a contraction, but in the same direction. So under H, you can actually see how the circumcircle collapses into this thing. Okay, so let me draw that circle. So the circle is something rather like this, isn't it? Nice. You can never get the 9-point circle right, when you're doing drawings on the blackboard, but it's all the same. Okay, so there we are. So this is typical. So this is in fact how mathematics works. This is in fact how science works. You happen, serendipity, whatever it is, you happen upon a fact. You find 9 points on a circle and you give a proof, okay, so if you're doing physics, you give experimental evidence, whatever you like, which is good. But you are, at the bottom of your heart, unsatisfied because you feel that although this is happening, there is something behind it, a big unifying picture behind it. In fact, it's exactly a miniature scientific revolution. You have noticed something, you have observed something, and now you have taken another step. You have looked at it from the point of view of an entirely different thing, from the point of view of homotheties, and you find that the unifying picture is obvious. The 9 points are on this circle, because this circle and the circumcircle are homothetic in 2 ways, and those homotheties have centers G and H. Yes. G, center G, ratio of similitude -1/2, center H, ratio of similitude 1/2. Center G, ratio of similitude -1/2. Okay? So if you do them both, you can see from the elementary geometry of the circumcircle of a triangle that these 9 points are on it, and that's the big picture behind the whole thing. Right, so that's going to be my sole example of the use of homothety. There are quite a few examples in which you can apply the concept of homothety in the problem sheet. Okay, so we have got about almost 2 weeks to work through the thing yourselves. Okay, well, all I can say is that I wish you have fun in your preparations for the final examinations. Well, that's the end of it. Thank you very much for listening. That's all.